if starch is going to hydrolyze to maltose because everything's clear. Now we could have other chemical or machines to help, determine this, but we're just going to use reagent colors. The solutions are clear. So how are we going to know if maltose appears? We just don't know if it's all clear. So we're learning that we need to use reagents. Okay, we're going to use Lugol's first to detect all of our variables here, except for amylase. Okay, because if you think about it, amylase and what we're doing with amylase, these are your experimental variables. These are what we want to test. Okay? The dependent variables then are this, starch and maltose, because essentially what we're trying to understand is the rate at which maltose is produced. So the rate at which maltose is produced depends on this, right? Okay. We know what we're going to do with amylase. We don't need a reagent to detect amylase. We know what we're doing because we're putting them in 3 conditions. So, but what we don't know is how we're going to detect starch and maltose, and if it's just water. Okay, so we use reagents. First, we're going to use Lugol's using a spot plate, just because that's what we have. You could use anything, really. Okay. So this is not even your experiment. We're just learning how to detect starch. So Lugol's can be used. Okay, so this is called your positive identification control for starch. So you notice this is like betadine, right? And that's kind of just what it is. So I'm going to go ahead and just add I think it's just a couple drops. I just said 1 drop. Okay, 1. Okay. Then we're going to add 3 things here. Okay. Water, starch, and maltose. We don't need to determine how amylase is going to change colors. We know what we're going to do with amylase. What we're not going to know when we do run the experiment, where is starch? Is it there? Is it disappeared? Is it hydrolyzed? Is maltose there? We don't know. Okay, so this is how we're going to do it. So Lugol starts off like this. This is the negative control. These would say negative controls. But what you're going to notice is and this is where I get confused about how many drops here. Do they just say 1 little drop of pipette? It's 2 drops. So they just say 2 drops. The other things are all 2 mLs.
Oh, yeah, 2 drops.
So 2 drops of just distilled water. You can just literally just do that.
I'm just gonna squeeze it. It's gonna like all shoot out.
Yeah. just the best that you can. That's okay. That's okay. That's okay. You'll see why. It's not a big deal. Maltose and starch.
Maltose?
What I think of, all these solutions are in water, so we need to make sure we know we're not just detecting water.
Is it 2 ml or 2 drops of that?
2 drops, they said. Okay, which is that?
Maltose.
Okay, now finally a drop of starch. Okay, you see which one is different. So that is starch. This was water or maltose, and this was water. Okay, so we're just gathering information that we have identified starch is going to change black. Okay, that's your positive control.
So this turned orange.
So if they stay orange, if it's staying orange, it means there's no starch there. If it's black, it means that there's starch. So we're going to use that information in our experiment. Okay, now how are we going to detect maltose at the end? Well, we're going to use Benedict's. Okay, so the positive control for Lugol's we just did, but now we need to do what we call positive control for maltose. So keep thinking, what is our big question today? Is starch breaking down the maltose? We do need water, so I think of these are your little variables that we don't know where they are because it's all clear. We know what we're doing with amylase. We need reagents to figure out what is going on in each of these situations. Where starch, maltose, is it just water? You see? So the control maltose at the end, you're going to have to take 3 test tubes. So you've got your water bath boiling, good. Have you gotten your control tubes ready?
No, I didn't know what to put in. It's
Yeah.
like 2 milliliters.
Yeah, and there's a lot of confusion. Because it's just a 1-to-1 thing. So just basically whatever you do for Benedict's, you do the same amount for whatever you're testing. So it's the same thing, water, starch, and maltose.
Oh, okay.
We're not talking about anything about amylase just yet.
I had to measure with this. Maybe we can
Oh, yeah.
And maltose, right?
Do
you need any
help? H2O, maltose, and starch. You can put 2 milliliters of starch in here. Okay,
Mhm.
starch, 2 milliliters of maltose.
Try not to cross-contaminate or really screw you up here. Do you guys have all the solutions that you need? Because we have some here.
Wait,
So we're gonna need smart because rules down to room temperature.
Yeah.
is that 2?
Yeah, it looks like
In
Wait,
here it's
it's
2,
like
but in the
every-
lines not 2.
I know because the lines we just
Because
did
it's
by
a little bit higher at the top. I think it's
centimeter,
fine, yeah.
which is
You
different.
So,
Okay.
should
Those
I follow
lines
this?
do not follow your millimeters.
Okay.
Before we did the marks, you can really do either way. But however amount you put of your test solution, you put the same amount as Benedict's, whether you're using the 2 black lines or the 2
2
ml
milliliters
method.
each.
Yeah.
Mhm.
Okay, 2 milliliters in each tester.
Okay, so Benedict's is in there. Now you'll add the same amount, 2 mLs of Benedict's to every.
So,
So okay,
water,
this is-
starch.
Yeah.
it's just water.
Yeah, you just think of whatever you need to use. Yeah. Okay, so when we add the Benedict's, we know it's going to start blue.
You know, I'm gonna experiment.